Perfect. Then stage is yours. Thank you.
Hello, everybody. My name is Emile. I'm a graphic designer and developer from Strasbourg in France. Today, I'm going to talk about Phosphor and Tectonic fonts. Phosphor is a small tool I developed mostly last year, and it's based on earlier experiments. It's a tool for creating outline fonts using plain text and a Python script. It's more on the experimental side of type design than a fully professional tool. Oh, here. Yes. Okay. So I'm not really a type designer, but I'm interested and curious about fonts. And to be more specific, I'm drawn to this kind of fonts. Probably because of its simplicity or versatility, it feels easier to understand and to create than outline fonts. Here, what you see is the default fonts from the Epson LX800, a 9-pins dot matrix printer from the mid-80s. These kind of fonts are sometimes called bitmap, pixel, dot matrix fonts. These days, I like to call them tectonic fonts. This is a term I borrow from Doug Clow's lecture, Time to Spare, Type and Tectonics. In this lecture, Clows explores the connection between typography and tectonic crafts, the crafts that are built through the accumulation of identical or similar units. He presents many examples of typewriter art, cross-stitch, bricklaying, or mosaics. And also, he reflects on the relationship between these crafts, work, time, and gender. So this is a preview of Phosphor to give you a general idea of how it works. In the background, in white, you can see a font created with Phosphor and opened in FontForge, the font editor. The glyphs are stored as text files and represented in text, as you can see in the left window. And each file includes a YAML frontmatter section with metadata, such as the glyph name, the left and right bearings, and the position of anchoring points for accented or composite glyphs. And at the bottom, here, we run the main Python script by passing a set of arguments, such as the glyph files, the font name, and the metrics. The script is very simple. It consists of 3 nested loops looping through the glyph files, the lines, and each characters. For each character, it calls the pin function, what you see in the top middle window, to transform the textual representation into vector graphic. And the pin function can be very simple, or it can describe more complex and expressive shapes. Here, very basically, I use dots and hashtags to represent the glyph, but you can use more than two values. These vector graphics are then assembled into an outline font using the FontForge scripting interpreter. Of course, representing a font in text is far from a new idea. There are many similar projects. Here is a short list. For example, you probably know some of them. Just for example, this is the Unifont initiated by Roman Dzibora. It's, as far as I know, the font with the widest Unicode coverage, and the glyphs can be represented and drawn as text. They are stored as hexadecimal values along with their Unicode IDs. And there is a small Perl script called xdraw, which converts between a human-readable representation and the hexadecimal format, and vice versa. And on Roman personal website, we can find their proposal for the Unifont. It contains many interesting and sometimes strong ideas about type design. For example, they question notions such as font quality and size and the degree of freedom it allows when drawing a character. They also reflect on the conditions for collective type design, as well as independence from complex tools through the use of plain text. This is a screenshot of the word processor Mac Write 1 from System 1, the original Macintosh operating system. With the exception of the Venice typeface by Bill Atkinson, the fonts were designed by Susan Kerr. And since they are bitmap fonts, she had to design each size separately. So they are not simply scaled. We can see small differences between each font, each size. And here on the menu, we can see the 5 available styles. So bold, italic, outline, shadow, and underline. The Macintosh could produce bold by widening vertical strokes and italic by shearing the image. The 5 different styles could also be combined with each other. So based on the original bitmap drawings by Susan Kerr, new fonts were algorithmically generated. And we can see weird things happening here and there, artifacts of the automated processes. Like in the italic style, it looks like the Y is missing pixels. Okay, yeah, I originally wanted to do a live demo, but while preparing the presentation, I realized that my live coding skills were not as fast and reliable as I thought. So instead, this is a short screen recording of me using Phosphor, which I will try to comment on. Video, yes. So I have some glyphs in my directory. Each file contains metadata, such as bearings and anchoring marks, as well as the text representation of the glyph. And when I run the Phosphor script with arguments, this generates SVG files of each glyph and the font files that I opened with FontForge. And here we can see the ascender, descender, and baseline, and the bearings. There are some utilities to help create or modify glyph files. For example, if I have a small b glyph, I can use the flip script to create a small d. Or I can also use the rotate script to create a small q. I have to use it 2 times, so. And then I just have to append the output to a new file and add the name and other metadata. There are other utilities as well, such as flip vertically, merge 2 files together, or reverse hashtags and dots, for example. Here I open my pin function file. This allows me to call Phosphor with the ellipse pin, for example, instead of the rectangle. And when I open the font, we can see the new output. Here I'm editing the size of the ellipse to make it bigger, very basically. So it gives us kind of a bold font. Here I am adding some randomness, so there is a slight chance the dot is not printed. So as you can see, this makes it very easy to generate a lot of glyphs and so make alternates. And here I'm just playing a little bit with the variables. For example, increasing the size of the dot depending on its vertical position. Okay. Yeah, more examples. This is the first font I made while experimenting with this workflow. It was created before I built Phosphor as a more, let's say, generic open tool to make other fonts. We can see different style generated from the same textual representation. And from the first output, it's easy to generate a bolder version or even an italic shifted version, the last one. And we can also perform more complex algorithmic operation. For example, we can check the Moore neighborhood of a cell and round the edges based on adjacent cells. It's the one in the middle. I don't know if you can see the rounded edges. Or, of course, we can introduce some randomness to generate more experimental and weird fonts. Fonts that probably don't have many practical use cases, but that I still find interesting, funny, or perhaps even beautiful. I'm the main user of this tool, but I've also had the opportunity to run small workshops on type design using Phosphor. And the biggest difficulty was probably installing the software and the dependencies on each participant's different operating systems, especially the connection between Python and FontForge. But I believe this has improved since then, and it's now easier to set up. And the participants were mostly graphic design or type design students with little to no experience in programming or the command line. So the tool can feel a bit intimidating at first, but it's from a pedagogical point of view, it's also quite easy to slowly and gradually modify and experiment with the example pins functions and generate new outputs step by step. So this is an example of a font generated with Phosphor during a workshop. And we also sometimes worked together collectively in real time using Etherpads. The collective drawing part was fun and quite easy to set up. But the Python programming was much more difficult because of the language strict indentation rules. So doing Python programming in pads is probably not a very good idea. Yeah. So this is the manual of a star LC dot matrix printer from late 80s, early 90s. Unlike many dot matrix printers from that period, there is a chapter in the manual about user-defined characters. And so in these printers, the default permanent fonts are stored in the printer ROM, but these printers also allow you to load new custom characters into RAM. So I don't know how much this feature was actually used back in the day, but what I find very interesting is that this kind of feature, or at least its documentation, it tends to disappear from dot matrix printer manuals in the mid-late 90s. And so like many other cases, features that give users a bit of freedom and room for experimentation are slowly removed by printers companies. And to maybe wrap up this presentation and maybe as a little teaser for tomorrow, this is a video of some recent experiments. It's a Phosphor to dot matrix printer script. It uses the same files as Phosphor to print text in a custom font, including the bearings, using a dot matrix printer. Thank you.
Thank you. So I think we have a couple of minutes for another questions. If there are any questions, there are one in the front.
Basically, just no question. Did you try to implement one of those fonts for the old printers, like push it into the RAM?
Yes.
The last thing you, so this is done
Yes.
with.
I'm not sure if I understood
You
correctly, but this is custom font, the one you see. But
so the thing you just showed in the manual that this, yeah,
this
nice.
is the kind of
really
thing.
cool.
Actually, I'm cheating a little bit because I don't have the right cable, and I think there is some weird things happening. So I'm more using the dot graphics, which is not the same as the fonts. It's almost the same functions, but the dot fonts are not really working yet because I need another cable. So I'm cheating. I'm making fonts using dot graphics.
Okay, two more questions on the side over there.
Thanks. I really enjoy seeing bitmap fonts. I've toyed with that once in a while myself. You mentioned something sort of in passing that in the font file, you can use more than 2 symbols in the grid. You said you could use a dot or a hashtag, but you could do more things. Do you use that to produce different output from the pen? Or
Yes.
like how, what does that look like?
So if you want, you can use any values like A, B, 1, 2, and more than 2 values, I mean. And you just have to edit and modify the pin function according to your drawing. So let's say I want to make an ellipse when I see a little hashtag, and I can make a rectangle when I see, for example, another symbol. And so,
Have you done that?
yes, Yes, I didn't show it, but one of the things that I believe is very nice to do is for the serifs, for example. You can make the sans serif fonts, and then you add the little serifs, but with another symbol. So you can run the sans serif and then edit your pin function and say, okay, now I want to print the serif. So they are going to be printed this way or this way. You can make module somehow. Like this is the bottom left serif. So I will call it with, I don't know, letter B, and the bottom right serif, something like this.
Cool. Same question. Okay, cool. Any other question? If not, thank you again for your talk.